Find the position of a point theta for which the electric field vector at that point due to dipole is perpendicular to the dipole vector. Okay. So at a general point, say the radius vector of the general point makes an angle theta with the dipole moment or dipole, and say the net electric field at that point P makes an angle alpha or pi. So you can take alpha or pi. So makes an angle pi with the radius vector. So now this pi plus theta together should be 90. That's what they're asking. Pi plus theta. So pi plus theta together should be 90. So what is this pi value? Pi is pi by 2 minus theta. Okay, so we have the relation between these two. So tan pi or tan alpha, both are same. Tan pi is equal to tan theta by 2. We have this. So if I substitute this pi value, tan of pi by 2 minus theta is equal to tan theta divided by 2. So tan pi by 2 minus theta is nothing but cot theta. So cot theta is equal to tan theta divided by 2. So this is also equal to tan square theta is equal to theta 2. Why? Because 1 by tan theta, cot theta equal to 1 by tan theta, it goes the other side, it becomes tan square theta. So tan theta equal to root 2. Tan theta equal to root 2. Theta will be equal to tan inverse of root 2. So this is the theta value for which the electric field at the point P, general point, should be perpendicular to the dipole.